Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new Redefining Security podcast. Have you ever thought that we are selling cybersecurity insincerely, buying it indiscriminately, and deploying it ineffectively? Perhaps we are. So let's look at how we can organize a successful InfoSec program that integrates people, process, technology, and culture to drive growth and protect business value. Knowledge is power, now more than ever. HITRUST is a leading data protection standards development and certification organization that strives to safeguard sensitive information and manage information risk for global organizations across all industries and throughout the third-party supply chain. Learn more at hightrustalliance.net.
Imperva is the cybersecurity leader whose mission is to protect data and all paths to it with a suite of integrated application and data security solutions. Learn more at imperva.com.
Marco.
Sean.
Have you heard of this new thing?
Sean.
Marco.
Sean. I heard about this Sean thing. I don't know what it is.
Right? No,
that's what we're talking about.
There's this new thing, the new Sean. I don't know.
The new Sean.
I don't know. I'm talking about this new fandangled thing, Marco, called the internet.
I heard of it.
Yeah, it's gonna rock the world.
You know what I heard?
Change how we do things.
I heard that it's on the internet. You on the internet? You on the internet?
You heard it on the internet? I don't know how you made that possible, but here we are. We're talking about this new thing called the internet while on the internet.
Yeah.
No, I think we're properly confusing everybody.
Yeah, that's what we do.
But I'm not being completely wrong here. There is a new internet. Doesn't mean there isn't one yet, right? So maybe we had the assumption that there wasn't one yet when I said that. But there is a new internet, and that's what we're going to be talking about today. And well, why do we need a new internet? And what does it solve? What problems are we experiencing in society, in business, and life that the existing one may not hold up to? And of course, I have no idea, Marco. Maybe do you?
No. We use the internet to connect with someone that knows about it.
That's right.
And so that's the proof of concept to see if actually internet, after so many years, still working somehow. We have Nicola Rustignoli. I'm pretty sure I pronounced that correctly because he's like me. He's Italian, but he's living abroad. He's in Switzerland right now. Hey, Nicola, how are you?
Hey, Marco, I'm great. Thanks a lot for having me here.
Yeah, it's our pleasure. So, Sean, should we start from who is he and why he's going to tell us about the new internet? What do you think?
I think we should start with who the new Nicola is first. Yeah. new to our audience, Nicola. It's a pleasure to meet you. I'm grateful that we had a chance to connect, and I'm very excited to have this conversation. So a little bit about you and your role as part of this research and everything else going on with the new internet.
So thanks a lot for having me here, Sean. So I'm an engineer at ETH Zürich in Switzerland. We are a research university, and actually we have been working for quite a while on this next generation internet called SCION. And my role is to really bridge the gap between our great research and industry, and that's why I'm helping organizations that are actually adopting this new internet. So that's really about taking the research and making sure that society can actually benefit from that.
I love it. And so maybe to set the stage, I know we kind of want to get to the current state and why we need something new. So I'm wondering, the research you and the rest of the team are doing, I'm wondering how that works. Are you looking for problems, or are the problems obvious and you're looking for solutions, or is it both? And are you presented with problems you have to find solutions for? How does that all work from the team there?
Yeah, that's a great question. So when you look at today's internet, well, in some way there are actually lots of problems that, especially from a researcher's point of view, are actually quite evident. And specifically, we work with interdomain routing. So that's really about getting the data reliably from A to B across the globe. And what we have seen over time is that, well, when we actually started 10 years ago, those problems were more familiar, more known within academia. And in the last few years, as the internet has become so fundamental in our lives, we are actually witnessing how those problems are actually really noticed by society. And that is because the internet today simply cannot keep up with all the growth and with all the new applications that are coming out. So, it's something that has been evolving over time, coming back to your question.
So is it really a matter of scale, and all of the, I'll call them flaws or blemishes, are exposed with the scale? And is it that we've been able to kind of work around and put makeup over the blemish for a long time and not really pay attention to it, or what's going on?
I think the problem is twofold. So scale for sure is a problem. And for example, when it comes to internet routing, the growth in routing table size, for example, has always been a scaling challenge. And the number of devices that connect to this internet just keeps growing, and there is no end in sight. And so that's one way where current approaches are sometimes showing their limitations. But on the other hand, this is not only about scale, but more about reliability. So 10 years ago, if your internet went down for 5 minutes, it would be, okay, fine, I'm going to try later. But today, when we actually control lots of things that are very essential to our daily life over the internet, then those little outages or those attacks that can cause your network to be down, they're not acceptable anymore because we just depend so much on it. I'm thinking about, let's say, controlling the power grid or controlling things that are so fundamental about our lives. And when you think about IoT, well, that's great. We are connecting all things over the internet. But what if we actually really need those things? What if the internet fails when you actually need it the most? And that's a bit the question that we have been looking at. So it's really beyond scale, even though scale is, of course, very important as well.
So let's go like a couple of minutes of history in a nutshell of the internet, right? We had a conversation not too long ago, actually a very short time ago, about playing games and how the gaming industry has become so demanding from a data perspective, virtual reality, 3D gaming, going from leveling up to like creating world and universes and so on. And one of the things that came out in this conversation with its two game developer engineer from big companies is like, we just cannot achieve with the internet that we have today the things that we could potentially achieve, even thinking about connecting so many people with different reference point on their avatar, for example. So this seems to me familiar. Like, in a nutshell, when we invented the internet, I didn't. I can tell you that. I didn't invent the internet. It wasn't for, did we have an idea that it would have become this omnipresent in everything that we do? And that is that why we need a new one? Like, knock it down, build a new one from scratch?
Absolutely. So when the internet was built, it was more of a small research community and a few pioneers that started joining all those local networks together. And when that happened, then they faced the problem of interdomain routing, which is basically figuring out how to transport data from one network to another network that is somewhere far away. And when that happened, well, initially, a lot of the early efforts in the internet were about ensuring reachability. So the main goal of the engineering behind the internet was to make sure that anyone could talk to anyone else no matter where they were. And I think the internet did really a great job at that, because today you can talk to a device that is pretty much anywhere on the planet. So I think this is a really impressive achievement. But on the other hand, when you actually look at the quality and the performance metrics of how this happens today, that's where I think what we have today with today's internet that is based on, for example, BGP for interdomain routing, that's where you really see the limitations of this early approach. Because back then, if you look back at the 80s when all of this was created, well, performance, for example, for applications like VR and gaming and so on, it was just not really a problem that people had. And they could not envision that this would last so long and that people almost 40 years later would still be using the same protocols. And that's where we are really hitting those fundamental limitations that we actually try to address with our research on the next generation internet, SCION.
They did something so good that they didn't even believe them that they did it so good.
Yeah, in some way, it is impressive that we still use it today. But the limitations are really getting more evident.
So limitations are one thing, flaws are another. And I'm wondering if in doing your research, if you make that distinction or not, because some of the things you pointed to in the notes, you talked about security and reliability. And being a security guy, I'm always looking at everything from the CIA triad: confidentiality, integrity, and availability, which touches those two things. So I'm wondering what are limitations and what are flaws, and what are some of the things that you're researching to help make things better in the new internet? Let's start there.
Yeah. When thinking about today's internet, I'd like to tell this with a metaphor. Let's think about navigation and, just ships going out in the ocean. When you look back at a few hundred years ago, sailors, they only had maybe a map and maybe a compass, and they could just choose, if they wanted to go somewhere, they could just choose the direction, and then they would just go and sail in that direction, and they had to wish for their best. They didn't know anything about what was ahead on their path. They didn't have weather forecasts, they didn't have GPS, they didn't have radars. And today, when it comes to navigation, ships don't go out in the ocean sailing like this anymore, right? They have a lot of tools. And when it comes to the internet, when you actually want to send a data packet to somebody, we are pretty much stuck at this 100 years ago, like in navigation. What you can actually do is that you send this packet to your first router, and then you can only pray for the best. You don't know anything about what path lies ahead. You don't know if this packet is going to go through some adversaries. You don't know if the path ahead has congestion or has performance problems. And that also means that you can, as an end user, you can't do anything about it, which is why when you want to, let's say, play online, then you can face this latency or performance issues, going back to what we were talking about before. And so the internet is a bit stuck at this point in time. And so for sure that is a really big problem when it comes to availability. And when I mean availability, I also mean performance, in the sense that applications are not really able to always perform to the level just because you're not able to choose your path. And besides that, there's also a lot of network-based attacks, for example, denial of service attacks and so on, that are very hard to prevent. And this is really because of how the internet works today. And that's because security was not really a thing when this was built. When it comes to integrity, going back to your CIA triad, well, not knowing where your data is going through, that means that you're also exposed to potentially your traffic going through some, let's say, unwanted entities. And if you look at today's internet, route hijacks are very, very common. And they're actually used in practice for doing lots of nasty things. So I remember hearing just a few months ago that people kept stealing cryptocurrency by basically redirecting some of the requests to those blockchains. And this has been happening many, many times. And that is because with today's internet, hijacks are actually very possible, even if you deploy the basic security protections that people have been trying to deploy to fix this, like RPKI. So traffic can always be funneled through a third party that maybe you don't really trust, and you don't want your traffic to go there, even if it is encrypted in some cases. So yeah, I think these are two massive issues that we're actually trying to tackle with SCION.
So let's dig in with how you're doing that, because what I'm And I know we talked a little bit about gaming as an example, and one might think of a kid sitting with a headset on and in a nice fancy chair with some cool music playing. But these technologies find their way into business as well, and it can become pretty serious. You mentioned earlier, maybe before we started recording, that you're doing a lot of work for the finance and maybe even critical infrastructure industries. And there's a lot at stake. Healthcare, example, is another one. There's a lot at stake when those entities, those sectors are using the internet to do their work. And if the internet fails, if the internet falls down, if it loses integrity, it can have a serious problem. So my question to you is, what is SCION doing to solve some of the problems you mentioned? And I'm wondering, how does that change how organizations view reliability and security, mainly in the area of privacy, for example?
That is a great question. So when it comes to the how, well, SCION started as a clean slate design. So the idea was to try to really think, how secure could an internet be? And this is why pretty much every operation that is performed on packets is always backed by very strong cryptography. There is always authentication and so on. So most of the attacks that happen on today's internet are actually impossible by design. One really interesting feature about SCION is that it is natively multipath. So that means that as a user, you can actually choose the path where your data travels. And actually, this is really interesting because that actually opens up a whole new range of possibilities. First of all, I'm thinking about reliability. So if you have more than one path, that means that if something breaks in the network, even if very far away from your end host, you can actually instantly fail over to a different path. And that's what gives SCION that extra reliability that in today's internet you don't have. And that is because today's internet can take even many minutes to actually react to a failure in the network. So this is a very interesting feature, for example, for business organizations, enterprises that are actually now starting to adopt SCION. Another really interesting one is that those SCION paths are actually fully authenticated. I think I mentioned that earlier. And that also opens up a lot of new possibilities that are not really available in today's internet. So for example, as a user, you can actually choose which piece of infrastructure is gonna route your packets. And if you're working in a highly regulated industry, let's say finance or military or government, that means that you can actually restrict your traffic to stay within a certain trusted boundary. And that really allows you to do actual geofencing on your traffic. And that, of course, that also makes you immune from all those routing and hijacking attacks that I mentioned earlier. So this has been resonating quite well, especially with the finance industry in Switzerland. And actually, they started adopting SCION exactly because of their compliance requirements that really pushed them to actually adopt a technology that could actually give them much better guarantees than what they actually could achieve with their legacy solutions.
So let me ask you something before Sean asks more technical question, because I'm like thinking as a user, thinking as a business or an organization. I'm like, all right, you're gonna give me a new internet. What does it mean for me? How do you migrate from this highway, let's call it, to drive on another one? I mean, do you need?
You need a new car, Marco.
Well, I'm thinking I need a new everything, and that would be very scary from a business perspective. So I'm thinking adoption-wise, how easy is it? And
absolutely, I
guess that's the question. How is it?
Yeah, that is a great question. So of course, we know that this approach of rebuilding things from scratch can be very high impact, and this is why when engineering this, we actually thought of many transition mechanisms that can actually help enterprises to migrate easily. So one of the first thing that comes to my mind is that, of course, we have a way to convert between the legacy IP world and the SCION world. So there is a gateway that can actually encapsulate and decapsulate traffic. And so when you think about an enterprise deployment, what you actually need is a small appliance at the enterprises that want to talk over SCION. And then traffic between those enterprises can be routed with all those additional benefits in terms of, let's say, compliance, reliability, and so on. So that in the end needs this additional device or piece of software somewhere in the middle of the network. And of course, you need some ISPs to provide SCION connectivity. And this sounds like crazy, but actually here in Switzerland and Europe, where this is really gaining lots of momentum, actually in Switzerland, we have all the biggest ISPs now. They really provide SCION connectivity, let's say, as a premium option for their customers, for the enterprise customers, which actually we find really impressive, as this, it was researched just a while ago.
I like how you say it's a premium.
So Nicola, I'm thinking like a security analyst sitting in the SOC, or perhaps a network engineer in IT, or maybe a firewall manager. Now, I'm just thinking that our networks are complex, and how we manage our edge is challenging. I'm just thinking how many thousands of firewall rules and IDS rules and all these things that security teams and networking teams have to put together just to defend from denial of service, defend from inbound scans and things like that. How does, from the perspective of a security professional, how does SCION change the way they look at their own network and the connections made to it? Does it free them from some of the challenges they have today, or does it add more? What does it do?
I think it definitely alleviates some of the challenges here. And I'm thinking, of course, about especially denial of service attacks and so on. And that is because many of them are in some way prevented by design in the architecture. One, if I want to summarize this in a nutshell, well, what we can say about SCION is that actually it provides network engineers with the same level of reliability that you have when you actually get a private line to somewhere. I'm thinking about like a leased line or an MPLS, but this is over the internet. So you have the availability and, let's say, bandwidth and so on guarantees of having a dedicated pipe. But at the same time, this is an internet. So that means that you need only one connection to talk to all your partners that have adopted SCION, which makes it a huge benefit in reducing complexity versus legacy environments where network engineers had to deal, for example, with a lot of leased lines for certain use cases, or where they had to deal with poor performance over internet, where they were using more some kind of like SD-WAN or those kind of solutions. So that definitely simplifies things. There are also mechanisms in SCION for providing, for example, packet authentication and so on. And those are more in the denial of service area. So that's where I think SCION can also simplify things. When it comes to firewall, I mean, in the end, SCION is about network and paths. And of course, one key thing about SCION is about trust. So when you configure a SCION autonomous system, you can actually very explicitly determine who you trust and who you don't. And this is really reflected in the cryptography that is actually used for packet forwarding. So if you say that you're, let's say, in the finance industry and you only want to trust your other peers in the finance industry in a certain country, you can actually do that in SCION. And that automatically shields you from a lot of background noise and attacks that actually come from somewhere else. And this is because forwarding is really impossible because of how the cryptography is actually preventing, let's say, the traffic you don't want. So you're really in charge of the traffic that you're allowing through. So that's where I think this can somehow simplify operations when you compare this to today's internet, where by default, everyone can communicate to everyone. And SCION just provides you that additional control. It still is an internet, so you can replicate this communication everyone to everyone, but you can actually specify it very clearly and very transparently how this works.
I'm glad you went to the cryptography thing, and then you mentioned trust as well and authentication, because the other thing I'm thinking about, and I'll use the three letters PKI, and most people listening to this episode will probably cringe. Managing a PKI environment is challenging. So does this help with that for the trust and the authentication? Of course, if the tunnel's encrypted, the privacy is maintained, and I don't know what the technology looks like from using blockchain like technology in there as well to help with integrity. Or I'm just thinking PKI sucks. It's good, but it sucks from a management perspective. How does this relate to that?
This is a very interesting question. So first of all, just to be on the precise side, SCION does not do encryption. So we leave this to the end user, but eventually we are able to provide cryptographic material and symmetric keys so that encryption can be very easily added. But this is not part of the core features of SCION that are more towards path awareness, routing security, and so on. When it comes to PKI, I fully agree with you that when it comes to today's PKIs, there are so many vulnerabilities, or well, not vulnerabilities, but let's say issues with the model and the trust model around it. And this is why SCION actually has its own PKI that is used as a basic layer for all the routing and forwarding operations. But there is a lot of extensibility, so the SCION PKI can actually be also used for additional applications. And we have some of them about packet filtering. I mentioned that we can easily provide symmetric keys between any SCION hosts. We can do this very quickly with a very low overhead, and so on. And without going into the implementation details, I think the most important thing that differentiates SCION from today's PKIs is about the trust model. So SCION is really built by design to be a multi-stakeholder architecture. And SCION has this concept of isolation domains that are a bit like a bubble. They're called isolation, but they can actually talk to each other. And each of them has a specific root of trust. And each isolation domain is somehow in charge of its own destiny cryptographically. And trust can be scoped to those domains so that you're actually able to choose who you want to trust. Maybe you're the finance industry, so then you want to trust, let's say you're Swiss and maybe American, and so on, finance industry. And that gives a lot of flexibility to decide how trust works. And that also allows you to have some kind of multi-stakeholder governance where each stakeholder is in strong control of their own area, but they're also more independent, both cryptographically and on the data plane, from what happens in other areas. And I think this is really differentiating SCION from today's PKI. If you think about the HTTP PKI, I mean, each browser is trusting so many certification authorities, and they are managed by so many different entities that, you know, this can be very, very tricky, because if one of them is compromised in this oligopoly model, then anyone can actually fake any certificate on your browser. So that PKI is, for example, problematic, and SCION also tries to improve on that side. I hope that gave you a perspective on this.
Yeah, it certainly does.
Topic.
Yeah, I know it is. We could be hours on it. Just maybe one more thought on this. Where we're talking about trust and connections and stuff inside, and there's this whole movement. It's not new, but the whole movement on zero trust. And I'm just wondering your thoughts on that and the connection with SCION to that model of operating.
Well, when it comes to zero trust, the idea is more to move everything to identity. We don't care anymore about network and so on. But I think SCION operates a bit at a lower layer. So SCION is really about building those strong and resilient pipes for the internet infrastructure to support, you know, all those kind of future applications. So I think we are really at different layers, right? Zero trust is more about users. But if everything is internet-based, and now that all applications are shifting to the cloud, everything is becoming internet-based. Well, what happens when you move applications from your data center to the cloud is that connectivity from your users to the cloud, to the public cloud, then becomes even more important. And so what SCION can do is that it provides you those very strong and resilient pipes for that communication to happen. So I think we are a bit at the lower layer. And But I think we can definitely be an enabler for zero trust and, for SaaS and, for enterprises to get rid of their data centers and so on.
Yeah, and I guess that was kind of my view on this, in that it's not a competing capability, and it's not adding more complexity. The pipe is the pipe. The fact that you pointed out is the pipe is no longer just inside, right? It's multi-cloud, hybrid cloud. Everything is going to be out of the data center using this pipe. More reliance and more trust is being put on that pipe.
So, Sean, the bottom line is that the cybersecurity people are still going to have a job. That's what I'm getting here.
Oh,
They're
absolutely.
still going to need it.
I would think so. Yeah, I think there's definitely room for some improvements still.
It sounds like, to use the metaphor of a highway or a new infrastructure where you can drive better car, faster car, maybe more secure car, because you have a better highway system in a way. That's a very simple way for me to take it, but I like metaphors. So tell me, Nicola, if I'm wrong with that.
Absolutely. I mean, you still gotta have somebody to engineer those cars and secure them and so on. I mean, there's applications on top of the network layer, right? And those still have to be secured and so on. So that's a very great metaphor.
So I'm gonna use that, because in a country, in a state, in a region, there are entities that design and build and maintain all that, usually at a government level. And sure, there's research going on for how to build a better bridge and which paths to take, freeways and roads, and how do you eliminate congestion in certain areas. And maybe that some of that falls outside of direct government control, and they hand that off to researchers and things. But I guess my question is, how does what SCION is doing move from research to commercial? Does it need to have governmental support? Does it go straight to commercial and it's a value drive there, or how does it break out of Switzerland's labs?
That is a great question. First of all, I think we're actually really hitting an inflection point where, if you look at those issues that SCION solves, for many years, they were a bit under the hood, in the sense that researchers were aware of it, but society, there was not yet this need for really reliable connectivity. And these days, we get approached by lots of governments, lots of businesses that are actually facing challenges with the internet. And then they realize, oh, you got this SCION thingy, and that's great. So that has been taking quite some momentum. And I mean, to this day, we have, especially in Switzerland and in Europe, a growing community of ISPs that are adopting this so that they can provide better connectivity, better premium connectivity to their customers. And this, I think, to these days, they're coming by themselves because they want to get SCION enabled. They have heard about us. They have heard about some of the early adopter stories. And so I think we are really getting in this momentum where things are really rolling. Well, of course, SCION is also a big ecosystem. It is an internet. So you will not be successful if you're the only one doing that, right? So you need a community. And this is why, even in my role, we are working on setting up the SCION Association. So that is really an entity that helps grow in this ecosystem. We are working on standardization and bringing SCION to entities like the ITF. We want to help companies to build more products. There's already an ETH Zürich spin-off, Anapaya, that builds commercial-grade routers and so on. There's multiple implementations, open source. We are helping the open source community. So it definitely started with support from academia and especially from ETH Zurich. But I think now it is really rolling, by itself, where the industry is really jumping on it. And I think a major milestone was actually the Swiss finance industry that is now using SCION for exchanging payment information. So whenever you pay somebody in Switzerland, then this information is actually going to go over SCION. And I think that was a major breakthrough because that really gave people confidence that this is not just research. This is something that works and actually works really well if you talk to the people that operate and work day to day with this technology.
And the primary, I don't want to call them consumers, but the people looking at this really closely are the ISPs. I think I heard you say. How about like CSPs? Do they have a role in this, or it's not the enterprise latching on to SCION directly, right? They're getting it through some service provider. Is that correct?
So normally ISPs, they provide this extra connectivity as a premium option, and they normally manage that, but that's quite open. I mean, we even have an open source where if you want, you can download all the code and run it yourself and do everything, or there's more managed solutions where you just get the connectivity layer and it's fully managed. So I think that really depends. And what we see from our perspective is that people more in research that are willing to experiment, of course, they try to do things by themselves. But on the commercial side, now there's really like commercial implementations that have all the bells and whistles for them to be managed. And it also comes as a service. So there's different levels, right? And that depends a bit on who you are. Of course, enterprises, they prefer the more managed solutions.
Yeah, I'm picturing a Google and a GCP providing this as part of their service rather than running on somebody else's pipe. But I don't know.
One day we'll get there. We do have some service providers that do provide cloud connectivity, and
right.
They can help, let's say, bring the SCION pipe as close as possible to those public clouds.
Yeah.
But there's definitely interest now that the ecosystem is really growing. I'm sure we'll get there.
Yeah. I guess you ultimately have to have the line itself.
Yeah.
All right. So
one day, you said one day, Marco.
I know. I heard that. I feel like that's the cue for me to jump in and talk about the future as we wrap this. So for society, I mean, we talked about business, security, better infrastructure, and all of that. But what does it mean for the everyday user? And I'm going to connect and throw the ball to you, Nicola, with the note that you had on what you shared with us about the Declaration for the Future of the Internet, and I have a copy here. And I gotta be honest, I'm gonna probably read this later in details, but I want to know how you mentioned that SCION is aligned to this vision for the Declaration, and of course the future. That's why we do all of this, right? We do it because there was a promise of the Internet. There is a vision for what it could be. There is something that needs to be inclusive, something that needs to be affordable, a democratic approach to the internet. Because let's be honest, especially with 2 years of pandemic, we have seen how the internet access is vital for so many functions in our society. So give me a view on how this is going to make things better for everyone. No pressure.
Yeah.
It's all on your shoulders, Nicola.
Yeah, no pressure.
I'll manage. So going back to that document, I think that came out from the White House actually just a couple of days ago. And that's really about a long-term vision about how the internet should be. And what really struck me is that many of the things that are actually in this declaration, for example, the fact that we want to have an internet that is stable, resilient, that is multi-stakeholder in the way that is governed, that it is decentralized. So, we don't want to have a single actor to be in control of everything. They even mention about the carbon footprint, and this is something that we're also tackling with our research on the green routing using SCION. So these are all things that are incredibly aligned with all the features and properties that SCION gives you. And so what really struck me is that now governments, and this is not only the US government, but many others that they're actually really reaching out to us. They're really realizing that that the internet can be better, that it has to be better than the one that we have today. And that is because if we don't do that, then we are going to miss a lot on all those new applications that are coming out there. And we talked about gaming and VR, but I mean, there's critical infrastructure that is that needs this reliable layer to be really controlled and managed over the internet. And when there's applications, then we're also looking forward to have SCION built into actually products that also end user leverage. And I'm thinking about, for example, browsers or providing reliable connectivity to blockchains. I think before we talked about people using routing hijacks to steal cryptocurrency, for example. And we have seen a lot of interest, and we are actually in touch with a lot of application developers that are really interested in adding SCION as this extra reliability layer into their stack. So I'm really sure we're going to see much more coming forward. And that's thanks to both applications adopting it and, of course, also governments realizing that this is really strategic for their, for the progress of their own countries. So I think it's a bit of a twofold thing, right?
Yeah, this is super cool. And then I know, obviously, being a security guy, I love hearing that reliability, trust, and security are built in from this clean slate. And it sounds like you're also thinking of the future in terms of scale in support of XR and VR and AR, VR, XR, whatever, SR. I heard another one the other day. Just this environment where there's going to be so much data from so many people and things for so many reasons and purposes that the current design is just going to fall over and not support a trusted, safe place to play and work and live and do everything we want to do. So I'm thrilled to hear this. And you mentioned one other thing, the green routing. I think that's also critical, right? We can't do this at the expense of requiring more energy and destroying the planet in the process. So I love that you have that kind of built into this model as well. I'm sure there's probably a whole arm of research around what that means and what that looks like, and who knows, maybe that's a separate conversation. But
absolutely, yeah. So, well, going back to scale, well, the S in SCION actually stands for scalability. So that is absolutely one of the top things that was thought of when this was designed. When it comes to green routing, yeah, the idea is to look at the carbon footprint of the internet. And as SCION is path-aware and can give you these very strong guarantees about where the data is forwarded, we have ongoing research to actually add to SCION packets some information about what is the carbon footprint of that packet, so that as an end user, you can actually select the path that has the lowest impact. Of course, this is at the moment very early research, but we are really glad to also try and contribute in that direction. Because if you look at the IT carbon footprint, it is something that has been growing for forever. And as we rely more and more on this, that there is just a lot of road ahead to do in this direction. So we are also trying to give our contribution there.
Yeah,
I
love it.
Sean, I'm really glad that you invited me to hear a lot of tech talk in a way, but I can really see that this need of, maybe it's because I'm in Italy right now and I'm thinking like, tradition and drive big car and street that were made for horses and carriage or even walking, and you don't want to knock it down. But when it comes to technology, I think that the clean slate change, I think most of the time is so much more beneficial for not only security, but environment, for speed, for adaptability. And so I'm glad to hear that there are, again, in academy, these things that are coming out, because that's I'm a big fan of academic environment, and that's really, I think, that's where the real future comes from.
Well, let me correct you. I mean, SCION is really getting real. Now it's really slipping out of the lab. Actually, it already did quite a while ago. And
no, but I mean, it was born there, right?
Yeah, of course.
As a research, then maybe you didn't know if it was going to be a big investment at the beginning commercially, right? You didn't do the commercial
absolutely
viability. You were just believing in something that was going to be better. So I understand that, and I'm glad that he's doing so, because that's a proof of concept for sure.
Exactly.
Yeah.
Exactly. No, I just think the core underpinnings are rooted in goodness, I think, is the main thing, not profit. And
absolutely. And I think to this, I also have to thank our professor Adrian Perry, who has been investing in this for a long time and really believing in in this vision. And I'm actually really impressed that those issues. He started working on this way earlier than me, and that's impressive that researchers could see some of those issues many years ago, and now you really see society catching up and realizing, oh, actually, this is really important. We need a solution for this. And we're like, yeah, of course, we knew about that. We've been talking about this for quite a while. Yeah.
I love it.
Very, very cool. And Sean, we already had few conversation with ETH, so it's getting better and better.
We're building a nice collection of friends there. I'm very appreciative of your coming. Bringing this to our attention and sharing your insights on behalf of your team and the whole group there. And I think for those listening, I suspect many have as many questions as we answered after listening to this. And thankfully, Nicola has already provided a number of links, which we'll include, and perhaps others, if he thinks of more that are relevant now that we've had this conversation. We'll include all of those in the show notes, so folks can connect to the university, connect to this program, connect to the science community, the education community. There's lots of, you mentioned the association. There's lots of ways to explore, learn, perhaps even get involved. And I would encourage everybody to at least look and explore what's going on here. So thanks everybody for joining this Redefining Cybersecurity here on ITSP Magazine. Glad you made it, Marco. Nicola, thanks again. See y'all.
Thanks a lot for having me. Yeah, it was a really great conversation. Thank you.
I appreciate it. Thank you.
Imperva is the cybersecurity leader whose mission is to protect data and all paths to it with a suite of integrated application and data security solutions. Learn more at imperva.com.
HITRUST is a leading data protection standards development and certification organization that strives to safeguard sensitive information and manage information risk for global organizations across all industries and throughout the third-party supply chain. Learn more at hightrustalliance.net. We hope you enjoyed this episode of Redefining Security podcast. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.